Hi all. Welcome back. In today's video, what we'll be doing is we will be going over an example of how to make a change in the Linux kernel code, build it and uh, run it and load the kernel and uh, run the new kernel and see if our changes have taken effect. Okay. So in order to do that, I have a project in mind, which I have already spoken about in my earlier video on a kernel module for reading the CPU temperature. So the goal is to turn on a fan, okay, that is connected to my GPIO, Raspberry Pi GPIO. Okay, so it is connected to my Raspberry Pi GPIO, and whenever the CPU temperature rises above 60 degrees Celsius, okay, I will turn on the fan. And whenever the CPU temperature falls below 55 degrees Celsius, okay, the fan will automatically turn off. Okay, so in order to do that, what I'll be requiring is I'll be also requiring the code for the GPIO interfacing with the GPIO from the kernel. So it basically involves the GPIO request API and a few other functions. However, I do not have a register right now with me, because of which I cannot, limit the current that is going through the GPIO pin. Because of which I won't be able to, demonstrate it using a fan. But what I can do is, I can just, print a message that turning the fan on, and turning the fan off whenever the temperature thresholds are met. Okay, and the main part of today's video actually is to do a code walkthrough. Okay, so many newbies to the kernel have this problem of walking through the code, because the Linux kernel code is a very big, it is a big code base, and it is very easy to get lost, and I myself am the victim of this quite a few times. So I will be walking through the code. I have already, done the walkthrough before, but I'll be showing how someone might, go do a walkthrough, how someone might figure out the code that is, uh, updating the temperature, and where we need to put in new code for turning on and off the fan. Okay, so I'll be demonstrating a working example today, and yeah, that is all actually, and we can begin with this the theory part now. So basically, some things you need to know about this thermal some terminology is that uh, there are trip points for every thermal zone. Okay, so if you don't know what is a thermal zone, then I would request you to go to my earlier video, of which a link I have put in the description already. Okay, so you need to go to that video and see what is thermal zone and which structures in the Linux kernel handle that and things like that. Okay, so every thermal zone has this trip points. Okay, and this terminology actually comes from ACPI documentation. So ACPI is related to this thermal management. Okay, on x86 based systems, you will find that if you print out the type of the thermal zone, then it will be ACPITZ, which is a thermal zone that is found on most x86 systems. Okay, so there are different types of trip points. Okay, so first is the active trip point. Okay, so active trip point is basically the trip point where try to cool the CPU using a fan. Okay, there can be several active trip points. Okay, and uh, as the temperature increases. So let us say we have two trip points, one at, let us say, 50 degrees Celsius, and the other is at 60 degrees Celsius. So the fan will be running at a lower RPM when it is at 50 degrees Celsius, and when the trip point at 60 degrees Celsius is reached, it will increase the RPM. Okay, so there can be several active trip points. Then there is a passive trip point. Okay, in when the passive trip point is reached, you try to do changes in the uh, CPU, how the CPU is executing things. Okay, so you either decrease the frequency at which the CPU is running, or what you can do is you can put the CPU or one of the cores or a combination of cores in idle state. Okay, so basically you don't submit tasks on that core or either the entire CPU, depending on how the code is written for that particular CPU. So for the driver, okay, CPU driver. So the thing is, when you put the CPU in idle state, uh, you are not running any instructions on that, so it consumes less power and its temperature decreases. uh, Also, when you are using lesser uh, smaller clock frequency on for running the CPU, again you are consuming less power, and because of that your the CPU temperature will decrease. Okay, then comes a hot trip point. Okay, the name of the trip point is hot. Okay, so hot means that it has really reached some uh, critical temperature, some important temperature, and now you need to act, like you need to either put it in idle, and uh, you might want to turn off some of the features on the motherboard, or uh, I don't know, there can be several things you can do when a hot trip point is reached. Okay, if anybody knows, you can also put it in this comment section, like exactly what things are done when a hot trip point is reached. And then lastly, we have a critical trip point. Okay, when a critical trip point is reached, you must that is a signal that you must shut down the machine. Okay, so these are the four types of trip points that we will be going over today in this video, which you need to know. And so today we'll be starting with the code walkthrough now. So let us first go to our best friend, that is this bootlin elixir, and let us go to the starting point, that is the thermal.h file. Okay, so let me go to include, then I will go to Linux, then I'll go to thermal.h. Okay, so in this thermal.h, uh, so basically, I am repeating this. So this is basically I am showing how someone might figure out how where you need to make the code change and how this entire flow is. Okay, so let me come down to uh, so today, so in this today's example, I'll not be using the thermal cooling device related code. Okay, so I'll be using a crude way to control the fan. Okay, but the real thing you should be doing using the Linux API provided by Linux. So yeah, so today we will be going over the uh, okay, so I'm using Linux 6.6. Let me load that file. Yeah. So over here, this is the thermal zone device structure. Okay. It contains these two fields which are very important. That is the temperature. Okay. And then it also contains something called the last temperature, okay? So which is exactly below the temperature field. Okay, so you might be thinking why there are two different fields, okay, for the same thing. It is temperature and the last temperature. So probably uh, someone might guess at this point, okay, who does not have the knowledge of the entire flow of how this code works. So he might be feel that he might feel that uh, the temperature is the latest, updated thing, and the last temperature is the reading that was taken before this one. Okay, and we need this change. Okay, we need this delta. We need to see this delta before making decisions. Okay, so for example, the temperature in our case, we need to turn on the fan after after it crosses 60 degrees Celsius or reaches 50 degrees Celsius. Okay, so in this case, it might be worth knowing that the temperature before was, let us say, 59 degrees Celsius, and in this particular when it this particular time when it was red, it went to 60 degrees Celsius, and now I need to turn on the fan. Okay, so if the last temperature field was not there, it wouldn't be possible to do that. Okay, so that uh, that is why these two fields are present here. Okay, now let us click on this and let us see how this is updated, in which function is it referenced, or how it is updated basically. Okay, so as you can see, it is referenced in various files, but the main one that we need to look at is in thermalcore.c. Okay, thermalcore.c is the main file where we will be seeing how the flow goes. Okay, much of the code today is going to be is residing in this file. So as you can see, the last temperature is being compared over here. Okay, with the so this is basically the function that is handling a thermal trip. Okay, so basically the trip is when the critical point is temperature point is reached. Okay, so if it is checking whether the last temperature is less than the trip temperature and so on. Okay, so let me just search for this last temperature field in this file. uh, as we can see, it is not being assigned anywhere in this part of the code. So let us uh, come down, and we can see that there is a very specific function called update temperature. Okay, which is setting this temperature. So as you can see now, the last temperature is being updated to the the thermal zone temperature, that is the earlier temperature that was red. Okay, and the new temperature is being set to the new value that was read from the sensor. Okay, the value was read using the same function thermal zone get temperature, which we have seen in the earlier video. Okay, so that flow you already know how it works. So we will go over this flow now. So we will just see how this update temperature function or where this update temperature function is called. So as you can see, it is called in the same file, and it is called over here thermal zone device update. Okay, so as you can see, this thermal zone device update, what it is doing is it is updating the temperature, it is setting the trips, and it is also generating a notify event. Okay, so notify events are basically the events which are generated whenever the trip points are reached. So let me just click on this and give you the uh, give you the list of all these notify event. this is an enum. Okay, so thermal event, unspecified, temperature sampled, trip violated, trip changed, and so on. So there are several notifications that are sent by the system. And actually, the thermal cooling device, that part of the code, it basically uses these notification events to do its stuff, like, either decreasing the processor frequency, or the processor clock speed, or turning on and off the fan. So this function is also calling the handle thermal trip function. Okay, but we need to right now, in order to understand the complete flow, we need to check where this function is called. So it is called again in the same file, but it is called at line 1556. Let us see what is over there. Okay, this is a thermal PM notify. I don't think we need that. Okay, so this basically thermal zone device update is a part of the thermal zone device update function. Okay, now let us go up in the stack and see, in the call stack, and see where this function is called. So as you can see, it is called in several files. Okay, but the I have actually already gone through this. So the thing is, I already know the flow, but if you go over this side, you will see that it is the hardware monitor, or HWMON. That is where uh, it is basically in the Raspberry Pi flow. It is being called over there. Okay, so if you go over this, so this basically someone might have to do some trial and error in order to reach this. Okay, but this is where the hardware monitor thermal notify function is present. And if you click on this, okay, so you might see that it is referenced in this file, in this function hardware monitor the notify event. Okay, and if you click on this function, you will see that it is called finally in the Raspberry Pi hardware monitor file. Okay, so Raspberry Pi firmware get throttled, and it is finally calling the hardware monitor notify event. Okay, so this is how the code is linked to the Raspberry Pi hardware monitor code. And if you just do an ls mod on any Raspberry Pi, you will see that there is this Raspberry Pi hardware monitor driver that is present. Okay, on every Raspberry Pi, which is, I think, doing the same thing. Okay. So now we also need to know where this function is getting, where the where. So when are we reading this temperature? Okay. So device is registered. We are over here. We already went through here. So this update temperature. So we need to know when this temperature is read. Okay. So is it something like polling, or is there an interrupt, or basically how this is being read? Okay. So in order to figure that, uh, let us go to mm, thermal zone device update. So we have reached this function called Raspberry Pi firmware get throttled, uh, which will be handling which has this function hardware monitor notify event. Now if we move one step up the stack, so this is referenced over here, and over here as you can see, get values poll. So basically the Raspberry Pi is polling on these sensors, okay, and then it is updating the temperature. Also you might be knowing that you might see that the frequency of polling, it is, so basically it is just scheduling this tasks, okay, after every interval, and it is reading the values. So this is basically the flow. So over here, the Raspberry Pi schedules this work for reading the data. Over here, it reads the data using it calls hardware monitor notify event. Okay, hardware monitor notify event calls. Uh, where did that function go? Mm, yeah, it calls hardware monitor thermal notify. Okay, so then hardware monitor thermal notify calls thermal zone device update. Okay, thermal zone device update calls thermal zone device update, uh, which is preceded by these what do you call uh, you know uh, which is preceded by these underscores. So this function thermal zone device update calls update temperature, and the update temperature function is the one that sets the last temperature and current temperature by reading the temperature at that particular point. So this is the complete flow of how this how this temperature is pulled and this temperature is set in the structure. So what now we will be doing is we will be modifying this update temperature function, okay, and we will be adding code to check whether it has crossed 60 degrees Celsius, and I'll demonstrate to you by, right now my Raspberry Pi fan is connected to the 5 volt and ground rails. So I'll just turn off and turn on the fan, and I'll actually demonstrate you how this code will work. Okay, so let's get our hands dirty and move over to the code. So I have this, uh, I am connected to my Raspberry Pi. Okay, let me open Visual Studio Code. So Visual Studio Code is open, and so let us see which file is this. This is thermalcore.c. Okay, let us go ahead over to thermalcore.c. So yeah, apologies for if the font is very small. Let me just go to settings and increase the font. Okay, now the code is, I think, clear. So let me make a code change over here. So over here I will say if mm, TZ's last temperature is less than 60 degrees Celsius. So over here the temperature is always read in milli-degrees of Celsius, because of which we will be typing in 60,000. So this is basically Linux code for the Raspberry Pi, which I have already downloaded. So if the previous temperature was below 60 and the current temperature is greater than or equal to 60, what we will be doing is we will be saying fan fan turned on. New line. Uh, it is very important to put a new line there, because once I had not put a new line over there in the code, and I was not able to see the printed output. So it is very important you put it. So that is for when the temperature goes above 60. Let us write the code for when the temperature goes below, say, 55. So over here, the first condition will be Pz's temperature, last temperature, greater than 55, and current temperature is less than or equal to. Okay, and in this case, we will print fan. Okay, so that is it with our code. Okay, so let us try and test this code, and just in order to demonstrate some other thing, that is, when you read the sysfs file which I had explained in the earlier video. So you read the temp file, right? So we will be setting we'll be printing something when the mode file under the thermal zone 0 directory is read. So let me just show you what I'm telling you right now. So let me do a cat sys class thermal zone 0, and then there is a file that is called mode. So instead of mode, actually I would prefer the type file. So type, basically, you might be knowing, it is the type of the temperature sensor. So type. So as you can see, it outputs CPU thermal. So we will be writing code where we will be displaying a print message once this file is read. Okay, and then in order to do that, you need to go to the thermal sysfs file. Okay, thermal sysfs.c. So over here you have temp show, you have mode show. Okay, so you also have type show. Okay, so this type show function is called when you are trying you do a cat on that type file which I showed right now. So let me add a print statement over here saying type has been read. Okay, so I think this is all with our code. It's not a very big chunk of code that we wrote. So what I'll do is I'll move to the directory where I have downloaded the source code, that is in desktop and Linux, and then I will do a make j6, and let's just wait for this code to build. So yeah, we are done with the kernel compilation. Uh, Actually, I had already built a kernel before, and since this was an incremental change, it did not take much time. And in the meanwhile, I also had to close VS Code because my Raspberry Pi has only 2 GB RAM, and it was slowing down the build process. Okay, so we have the uh, image. The image is zipped. Now what we need to do is we need to just we need the command to copy the image. So it is this command over here. We need to override the current image with this image, and then we just need to do a reboot. So coming here, so I need to change this kernel variable since I have not defined it. It is kernel 8 for my configuration. Okay, so now we are done copying the new image, new OS image, and now we will just do a reboot. Okay, we have rebooted the Pi and we are back. So let me first try to read that type file. Okay, so over here, let me just zoom in so that you will be able to see. Okay, so you are able to see now. So I'll type cat sys class thermal. Okay, sorry, before doing that, I need to show you the D message output. Okay, so D message is not printing anything right now related to what code change we made. Now we will do a cat sys class thermal thermal zone 0 and type. So the type over there is CPU thermal. Now let me do a D message, and as you can see over here we can see whatever code we inserted is being run. So type has been read. This was the print statement that we had added. Now let me just see what is the processor temperature. So right now the processor temperature is about 44 degrees Celsius. Now what I'll do is I will just turn off the fan, and what we can do is we can let the CPU temperature rise above 60 degrees Celsius. Okay, and then uh, we will see whether our code is working, and then I'll turn on the fan, and then we will see as it drops below 55 uh, whether our code is working. Okay, so let me turn off the fan now. Let me manually turn off the fan. Okay, I have manually turned off the fan. Now let me just see what is the processor temperature. Okay, it is somewhere around 43. So what we need to do now in order to increase the temperature, so some things that we can do is we can set the uh, CPU governor to performance. So sudo CPU frec set -g. Okay, so this will help in increasing the temperature. Let us see what is the temperature. Okay, it has gone up to 45. What I can do now is actually I can undo those changes which I made in the code, and I can run and I can build it again. This will further help in increasing the temperature. So over here, let me just delete this line. Okay. Let me delete these two lines of code also. Okay. So let us see where we are. Okay, nice. So it has gone up to 57 now. Uh, Probably if I build the code now, it will go up above 60. So let me do that. Uh, Desktop Linux. So I'll be building the code now. Probably after this build, we will see that the temperature has gone above 60. So let me open another terminal. Okay, cat sys class thermal zone 0 temp. As you can see, the temperature is now 62 degrees Celsius, about 62 degrees Celsius. So we can just see the D message right now. So as you can see, uh, we can see that the fan has been turned on. Okay, this is the latest message. Probably the temperature fluctuated before, and because of which uh, there must be this fan turned on and off thing. Okay, so what I will do now is let me turn on the fan manually, and let me decrease the temperature below 55. Okay, so I have manually turned on the fan. Okay, now what I'll do is I'll just close the editor. Okay, let us try reading the temperature. Okay, it is at 64. Probably after this compiles, it will come down again. Okay, let me set the governor again to power save. Okay, now we should be seeing the temperature drop very rapidly. Okay, so it has directly come down now to 47. Okay, let me see D message. So after that, you can see that there were some fluctuations and finally the fan has been turned off. Okay, so this is basically demonstrating how you can adapt a crude uh, cooling solution for your Raspberry Pi. I hope this video was informative and yeah, that's all. Let me know if there are any suggestions or if you would like to see any other code in the comments. And that's it for today. Bye.